In this video, we'll use the zero product property in order to solve some equations. The zero product property states that if you have two real numbers, a and b, and you multiply them together, and the answer is 0, then one of those two numbers must be 0. This makes a lot of sense, thinking about some unknown number a times some unknown number b equaling 0. The only way that could happen is if one of them is 0, or both of them could be 0. But we know for sure at least one of them is 0. This simple property allows us to solve a lot of different sorts of equations. Let's take a look. I have the equation 3x times x minus 5 times 7x plus 2 equals 0. Notice the form of this equation. The left side is factored. It is three different quantities multiplied together. The expression 7x plus 2 multiplied to the expression x minus 5 multiplied to the expression 3x. And if I have these three expressions multiplied together and the product is 0, it must be the case that either 3x equals 0 or x minus 5 equals 0 or 7x plus 2 equals 0, according to the zero product property. It could be all of them are 0, one of them are 0, or just two of them are 0. But the solutions to the equation would be any x values that make the left side equal 0. So it could be that the 3x equals 0, which would mean x equals 0. Or it could be that the x minus 5 equals 0. Solving, we see then that x would have to be 5. Or it could be that the 7x plus 2 equals 0. And solving that, we see that x would have to be negative 2/7. Any of these three solutions will work to make the left side equal 0. So this equation has three solutions. X equals 0, x equals 5, x equals negative 2/7. To solve the second equation, again I'm going to note the form. The left side this time is not factored, so the zero product property does not apply here. I cannot state that just because x squared minus x minus 12 equals 0, that would not mean that 12 or x squared equals 0. These things are not multiplied together, they're added together. But if I could rewrite it in factored form, then we'd be able to use that zero product property. I'm going to rewrite it by factoring it. I'm looking for two numbers that multiply to negative 12 and at the same time add up to negative 1. That would be negative 4 and positive 3. So what I've done here is I've rewritten the original equation. X squared minus x minus 12 equals 0 is the same thing as saying x minus 4 times x plus 3 equals 0. Now I have one expression times another expression equals 0. In order for that to work, it must be the case that either x minus 4 equals 0 or x plus 3 equals 0. One of those two things must be 0 or both. If x minus 4 were 0, that would mean x is 4. If x plus 3 is 0, that would mean x is negative 3. So the two solutions to this equation are x equal 4 and x equal negative 3. Again, I first observe that this equation is not written in factored form. It's in expanded form. So I'm going to try to factor it in order to allow me to use the zero product property. I first factor out the greatest common factor, which this time is 3x. I pull 3x out of 3x cubed, leaving x squared. I pull 3x out of negative 30x squared, leaving negative 10x. I pull 3x out of 75x, leaving positive 25. And that equals 0. Now there is a 3x out front, and I need to factor x squared minus 10x plus 25. I need two numbers that multiply to positive 25 and at the same time add to negative 10. That would be negative 5 and negative 5. Alternatively, we could write this equation as 3x times x minus 5 quantity squared equals 0. Either way would be fine. Now I have written this as a product. 3x times x minus 5 squared equals 0. Two expressions multiplied together equals 0. In order for that to happen, it must be that either 3x equals 0 or x minus 5 squared equals 0. To make 3x equal 0, we can divide both sides by 3, and so it must be that x was 0. To make x minus 5 squared equal 0, you could take the square root of both sides. The square root undoes the square, leaving x minus 5. Square root of 0 is just 0, and so x would have to be 5. So again, there are two solutions to the original equation. The two solutions are x equals 0 and x equals 5. And lastly, I want to solve the equation 6x squared minus 7x equals 3. It'd be great if I could use the zero product property. The zero product property says we need to have factored quantity equals 0. So first, I'll rewrite it so it is expression equals 0. To do that, I can subtract 3 from both sides. When I do that, I now have an expression 6x squared minus 7x minus 3 equals 0. Now I need to factor the left side so that it is in factored form equals 0. This time I cannot factor out a greatest common factor. There's nothing to factor out. So instead I'll use the AC method. A times C is 6 times negative 3, which is negative 18. I need two numbers that multiply to negative 18 and at the same time add to negative 7. The numbers would be negative 9 and positive 2. Make my little table, 6x, 6x from the leading term. The two numbers I selected were negative 9 and positive 2. Simplify, simplify. I pull a 3 out of the 6x, leaving 2x. I pull a 3 out of negative 9, leaving negative 3. So one factor is 2x minus 3. Simplifying 6x over 2, I pull a 2 out of each term. 6x divided by 2 leaves 3x. 2 divided by 2 leaves 1. So the other factor is 3x plus 1. Therefore, the left side of my equation factors as 2x minus 3 times 3x plus 1 equals 0. Now I have expression times expression equals 0. So it must be the case that either 2x minus 3 equals 0, or could be that 3x plus 1 equals 0. Solving for x, I have 2x equals 3, or x equals 3 halves. The other answer, I subtract 1 on both sides, so 3x is negative 1. Divide by 3, x is negative 1/3. So my two solutions this time are x equals 3 halves and x equals negative 1/3.